So now look at these guys. You see? Systems, your favorite. Look at all these variables and all these numbers. Luckily, we can solve these with matrices. So here we go. I'm going to turn this first system into a matrix. I'm going to first start with the coefficients, then the variables, then the answers. So in the beginning, when I start with my coefficients, I get this. You see where I got that from? I have 2, 3, then that's 1 there, and then -1 here. All right, that's how I got this one. The next one I'm going to get it is my variables, because you notice that the coefficients are multiplied by the variables. So I'm going to multiply this coefficient matrix by the variables. And here we go. Now, here's the thing. Some of you might have been thinking, well, wait, that's not how I pictured multiplying it in my head. I know some of you probably thought of doing, multiplying it like this, x and y. Well, why can't we do that? Remember, look at the order of this matrix. It's 2 by 2. So then this one has to be a 2 by 1 because these two must be the same in order to multiply them. And since those two are the same, that means that my solution, my answer is going to be this 2 by 1. And I'll show you that right here. All right, so now that we have our equation, we need to make sure that we treat this just like any linear equation. That's why in the beginning you saw this. You saw ax equals b. Well, here's our A, that's our matrix A. This is our variable matrix X. And these are the answers to the system's equation, that's B. Now what we want to do is we want to get those variables, this variable matrix right here by itself. In order to do that, we have to move A. And it's not as simple as just dividing like a regular linear equation. What we have to do is get rid of A on this side by multiplying it by its inverse. And if we multiply by the inverse on that side, we also have to do the same thing to the other side. So it's going to be A inverse A variable matrix equals A inverse B. See how I did on the same exact side? Got to do the same thing. Now the reason why we do this is because, remember from the last lesson, if you multiply a matrix by its inverse, you will get the identity matrix. That's what we want. It's like treating it as 1. So it's almost like 1 times x equals, and then our answer will be this, A inverse times B. That will give us our answer here. But first we got to find the inverse. Well, remember, the inverse is going to be like this. A inverse equals, and if it's a 2 by 2, we have to do this by hand. A inverse is 1 over the determinant of A times, we had A, B, C, D here. Now we're going to have D, negative B, negative C, and A here. All right, so let's find our determinant first. So if we have a matrix, matrix A is, A, B, C, D, we have to do the determinant of A equals A times D minus B times C. And if we do that here, we'll get A times D is 2 times -1 minus B times C, so that's 3 times 1. This is going to give us 2 times -1 is -2, minus 3 is going to be -5. That's our determinant. Now the formula here for the inverse says, okay, take 1 over the determinant, 1 over -5, multiply it by this new matrix. So D first, so it'll be -1, then negative B, -3, negative C, -1, and then A, 2. It's a scalar multiplication. We take 1 over -5, multiply by everything here. That's going to give us 1 over 5 here. And then it's going to give us 3 over 5 here. And then it'll give us another 1 over 5 here. And then lastly, it'll give us -2 over 5 in the last one. So that is our inverse matrix. So now we have to do this here. Multiply the inverse matrix by B. So I'll say this times B was 3, 4. And when we do that, we will end up with 3, -1. So if we go back to this here, it'll be saying that X and Y equals 3 and -1. See, pretty simple.